Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to solve some more questions from the part B of December 2023 exam. So these are the 4 questions that we are going to solve in this video. So let us see the first question. Molecule B is twice as heavy as molecule A. So what is the meaning of this? Let us keep on writing the given data as well. Mass of molecule A is twice as heavy, means mass of B is twice as heavy as that of mass of A. Okay, the ratio of thermal De-Broglie wavelength of molecule A to B will be. So what is the formula for thermal? What is the formula for De-Broglie wavelength? Lambda is equal to h by p. H is Planck's constant. P is what? Linear momentum, and linear momentum is m into v. Now if you use this formula, let's say lambda is inversely proportional to mass, and suppose you use this formula, and let's say lambda or wavelength of molecule A divided by wavelength of molecule B will be mb by ma. Okay, mb by ma will be, from this equation it will be mb by ma is equal to 2 by 1. Okay, so if you use this formula and suppose you have marked answer option 2, so that is going to be incorrect. Why? Because in this formula what we write is, okay, in this formula of De-Broglie wavelength, what we write is this lambda is what? It is De-Broglie wavelength. Okay, it is what? It is De-Broglie wavelength. And what is asked to us? Okay, De-Broglie wavelength is asked to us? No. What is asked to us is thermal De-Broglie wavelength. So is De-Broglie wavelength same as thermal De-Broglie wavelength? No. So what is the difference? The difference is you use the same formula, but you introduce the term of kinetic energy. Okay, so what is kinetic energy? We know half into m is mass into v square. V is velocity, m is mass. Now I can multiply numerator by m, denominator by m. Why I am doing this? Because I want to replace this linear momentum in terms of kinetic energy. Okay, so this will be half, okay, 1 by 2m into m is m square v square. So m square v square, I can write it as m into v the whole square. So this is p square by 2m. Okay, linear momentum is mv. P is linear momentum, m is mass into v is velocity. So this now, okay, let's rearrange. P square by 2m is equal to kinetic energy, I will write it as k. Okay, so what will be P? Cross multiply 2m into kinetic energy. P square will be this. P will be root of 2 into m into kinetic energy. So what is our thermal wavelength, or I can say lambda T? That will be h divided by, now substitute this value, 2 into m into k, kinetic energy. Now what we have got is called as the thermal De-Broglie wavelength. So what is the difference between De-Broglie wavelength, this lambda, and thermal De-Broglie wavelength? Thermal De-Broglie wavelength is what? It is the average of the De-Broglie wavelength of all the gas molecules. Okay, it is the average of the De-Broglie wavelength of all the gas molecules. Now you can compare. Okay, what is lambda T? Lambda T is inversely proportional to root of m. Okay, so I can erase this. What we got is lambda T is equal to h by root of 2m into kinetic energy. So lambda T is inversely proportional to root of mass. So what was the given data? Mass of B is twice as heavy as mass of A. Okay, so lambda, okay, thermal wavelength of, we want the ratio of A to B. So thermal wavelength of A to thermal wavelength of B will be root of, okay, it is inversely proportional. So it will be m of mass of B divided by mass of A. Okay, so from this what we can get? mb by ma will be 2:1. So substitute this, root of 2 by 1, square root of 2 will be root 2 divided by square root of 1 is 1. So what is the ratio? Root 2 is to 1. Okay, so it's very, very important to read the question very carefully. What is asked? De-Broglie wavelength is asked or thermal De-Broglie wavelength is asked. Okay, so the correct answer will be option 1 and not option 2. Okay, now let us see the next question. Of the following atomic transitions, the allowed ones are. So for this you must know some selection rules. Okay, there are certain selection rules that we have to follow. Okay, the transitions that follow the selection rules, are what? They are allowed. Rules are allowed transitions. Okay, so what are the rules? First one is change in the spin multiplicity. Okay, it should be 0. Change in the spin multiplicity should be 0. What is spin multiplicity? It is 2 into total spin plus 1. Okay, how do you write down? Okay, if we write down the term symbol, ground state term, what it would look like? 2s plus 1 L and J. Okay, so this 2s plus 1 is nothing but the spin multiplicity. That is what we write as the superscript. So what is the spin multiplicity? For example, these are the spin multiplicities. Okay, so using this rule, it should be 0. That means S2 minus S1, that is 2 spin multiplicities should be what? It should be same. This is equal to 0. So the spin multiplicity should be same. Okay, it should be same. It should not change. So we can eliminate this option. Here you can see spin multiplicity is changed. So this is incorrect. Here also this is changed. So this is also incorrect. Okay, here 1 minus 1 will be 0. 3 minus 3 will be 0. So any one of these can be the correct answer. Okay, how do you distinguish? That we can do by using the second rule. Okay, change in the L. Okay, L or the term. This should be plus or minus 1. Okay, this should be plus or minus 1. This is called as spin selection rule. Okay, the first one is called as spin selection rule. This is called as Laporte selection rule or Laporte's rule. Okay, so S, P, D, F, the L values if you write down 0, 1, 2 and 3. Okay, so now let's find out the delta L. So delta L for this will be, for S it will be 0, for D it will be 2. So delta L will be 2 minus 0, that will be 2. So does this follow Laporte's rule? No. So that is why this is incorrect. D and P. For D it is 2. For P it is 1. So delta L will be 2 minus 1, that is plus 1, or reverse also you can do 1 minus 2. Okay, 1 minus 2, that will be minus 1. So plus 1 or minus 1. So this one follows the second rule as well. So what is the correct answer? The correct answer will be option 4. Now let us see the next question. In FCC packing of monoatomic solid, the number of tetrahedral and octahedral holes in the unit cell are. So what is the tetrahedral holes? Formula for tetrahedral holes. How many tetrahedral holes are present? Tetrahedral holes is equal to 2 into n, and octahedral holes is equal to n. So what is n? N is the number of atoms in one unit cell. Number of atoms in one unit cell. Okay, it is for FCC. So for FCC we know total atoms if I want to calculate in one unit cell. Let's say first we find out for the corners. Corner contribution is 1 by 8 into there are 8 spheres. Okay, plus the spheres are present at the faces as well. There are how many faces? 6. Into contribution is half. So 1 by 8 into 8. This will be 1 plus 2 3s are 3 into 1 3. So total 4 spheres are present. We know this, right? So tetrahedral there are how many number of holes? 2 into 4 8, and octahedral it is Octahedral is equal to n. N is what? N is 4. So tetrahedral and octahedral. So the answer will be 8 and 4. 8 and 4. So the correct answer is option 1. Okay, this is very simple. Instead of this, next time they can ask for BCC. BCC n is what? N is 2. The tetrahedral holes will be 4 and octahedral holes will be 2 for BCC. So that way you can remember. Okay, now let us see the next one. Okay, so this question is for 0.001 molar aqueous solutions of aluminum trichloride, CaCl2 and KCl, the correct order of Debye length is. So for this you must know, if you do not remember this entire formula, this is the formula for Debye length. It's called Debye-Huckel. Okay, it is lambda d, or it is also represent sometimes as K inverse. Okay, Debye-Huckel length. This is called as Debye-Huckel length, or simply it is called as Debye length. Okay, what is epsilon naught? It is vacuum permittivity. Epsilon r is relative permittivity. Kb is Boltzmann constant. T is temperature. Then Na is Avogadro's number. Okay, E is what? Charge. Okay, in Faraday, charge, and I is the ionic strength. So what is important for us is we must know that lambda d, that is the Debye-Huckel length, is what? Inversely proportional to square root of the ionic strength. This is the piece of information that we must know. Even if you do not remember this entire formula, for this question at least this much information if you know, that will be enough. Okay, and what is the formula for ionic strength? That is also given here, half into summation of Ci into Zi square. What is Ci? Ci is the concentration or molarity of the ion, and Zi is the charge. So what we have to do is we have to calculate the ionic strength for all the molecules. So first one is AlCl3. Okay, AlCl3 will dissociate to give one Al 3 plus ion plus 3 Cl minus ions. So what will be the ionic strength? Ionic strength will be half into, okay, before that the concentration of this is 0.001. This is 1 ion, so this will be 0.001. This will be 3 ions, so 3 into 0.001, that will be 0.003. Okay, so now we have to use these concentrations. Okay, 0.001 and 0.003. So first let us write down for cation. What is the concentration? 0.001 into charge square. 3 square is 9 plus, here it is 0.003 into charge square. Charge is minus 1, square will be 1. Solve this. 9 into 0.001, that will be 0.009 plus 3 into 1, 0.003 into 1 will be 0.003. Okay, 9 plus 3 is 12. So this will be 0.012 divided by 2, that is 0.006. Okay, similarly you can find out for second one. Second one is what? Calcium chloride. Okay, calcium chloride, 1 Ca2 plus ion plus 2 Cl minus. Okay, so ionic strength will be, before that write down the concentration. This is 0.001. So this will be 1 into 1 ion. So 1 mole is present. So 0.001. 2 moles are present. So 0.002. Okay, now substitute. Half into, for calcium concentration is 0.001. Charge is 2. 2 square will be 4 plus 0.002 into charge is minus 1. Minus 1 square is 1. So half into 4 into this is 0.004 plus this into 1 will be 0.002. So this will be 0.006 divided by 2, that will be 0.003. Last one is KCl. KCl you can remember, that is 1:1 electrolyte. For this ionic strength is same as the concentration, that will be 0.001. Okay, we can calculate as well. K plus plus Cl minus. So this is 0.001. 1 ions are present, so 0.001. This will also be this much. Now ionic strength will be half into, okay, half into, for potassium ion concentration is 0.001, charge is 1 square plus 1 square is 1, okay, 0.001 into minus 1 square is 1. So this will be 0.002 divided by 2. It will be same as the concentration. So instead of solving that, to save time, you can remember that whenever there is 1:1 electrolyte, KCl, or let's say ammonium nitrate, this is also 1:1. So for these type of compounds, the ionic strength will be same as the concentration. Okay, so now let us write down the concentrations that what we have got. Okay, ionic strength for AlCl3, for CaCl2, and for KCl, this is 0.006. okay, this is 0.003, this is 0.001. So if I want to write down the ionic strength, order of ionic strength, it will be KCl less than CaCl2 less than AlCl3. But now if I want to write down for the Debye length, it is inversely proportional. So the order will be reversed. AlCl3 less than CaCl2 less than KCl. So this is the correct answer. So find out where is this option, AlCl3 less than CaCl2 less than KCl. So the correct answer will be option 1. Okay, so I hope you have understood this formula and how we can calculate ionic strength. Okay, and you don't have to remember this entire formula. Okay, this piece of information will be enough for at least for this question. Thank you.